good morning. Is this thing on? Can you hear me?
Yeah.
Excellent, that is good. I didn't sleep tonight. I'm super unprepared. I'm probably going to do overtime. I'm not a native speaker. I have no idea about the topic, but I hope the talk is going to be fun. So let's see where we can go with this. I want to talk about ToStaticHTML for everyone. That sounds a bit cryptic, and probably not too many people in the room might know what this is about. So let's tell a little bit of a story. This is Alice. She's like a superstar in crypto papers. Everybody knows her. And she wants to write an encrypted message and send it to Bob. And this is Bob. He wants to receive that encrypted message from Alice. And it's going to be about NASCAR or some stuff, so this is a bit weird. You don't have to be ashamed about these things, but you would consider that already privacy sensitive. So what the two want to do is they want to exchange encrypted mails with each other. But they're not too super tech savvy, so they don't want to install like Thunderbird and connect all their accounts and do these things and set up an unique mail and whatnot. So they want to have a comfortable solution that even works on the mobile phone and on the road. And they decided to use Electron Mail. I guess you all know what I'm referring to, so if not, Google it out or Bing it out. It's a fancy tool that allows to encrypt and decrypt mail messages right in the browser. So they can log into a web interface, receive the email, and it's encrypted, and then they decrypt it, and it shows in the browser, which is pretty cool. So that's a great software. And it makes sure that no one can read that message that the two are exchanging unless they have the proper key, which is a good thing. I guess we all know the principle behind that, and the only way to actually crack the code and get access to those messages in plain text is pretty much if you're very, very, very good at mathematics. And the approach that is being chosen here is often being referred to as end-to-end encryption. So Alice encrypts something, sends it out as encrypted text. Bob receives this, decrypts it, and then he can read it. And that's pretty awesome. He can even reply. So end-to-end, E2E, or however you want to call it. So from a technical standpoint, that is very easy to explain. However, something happens. The story has a twist. Actually has a bunch of twists, but this is the first twist. The next day, both Alice and Bob receive a message from Mallory, malicious Mallory. And they both open that mail, and boom, the account gets compromised. And they don't even notice. It's happening inside the browser. Not in the browser core, but in the HTML and in the JavaScript. Like, how is that even possible? Well, the interesting thing here is that Mallory herself gets access to all the emails that Bob and Alice have been exchanging in the past. She also gets access to the private keys. She also gets access to all the contacts in Alice's and Bob's address book. And she installs a keylogger, because just in case, you never know. And this attack really happened, and it is possible, and was demonstrated by a fellow researcher that I know in a presentation given in France on Hack in Paris last year. Now the question is, how is that possible? We mentioned already that if you want to crack the code and if you want to get access to the plain text of that message, you have to be really good at math. Mallory isn't that strong at math. I'm neither, so that's not a bad thing. And she doesn't really know too much about buffer overflows or use after free, so all those fancy things that Ben was talking about. She has no idea about these things, and I don't either. And she's further not in position of a vast attack infrastructure. So she doesn't have a bunch of number crunchers or GPUs or whatever setup that would be helpful in actually brute forcing or cracking that code, getting access to the messages in plain text, and then even moving beyond. She can't do that. But how did she do it? Well, she's pretty good at HTML. I'm also pretty good at HTML. She's also pretty good at JavaScript. And I would go as far and say that HTML and JavaScript are pretty much the modern cybercrime action pack, because you can do whatever you want with it as long as it's happening in the browser or something browser-like. So what Mallory was doing here, she was using a cross-site scripting attack. Who here knows what cross-site scripting is? Almost everybody. If you don't know it, look it up. It's super fascinating. It's not boring. So what she did, she was using a cross-site scripting bug, in short, XSS. And she managed to smuggle executable client-side code, HTML and JavaScript, into the message she sent out to Bob and Alice. And this code executes in the DOM, in the document object model used by Electron Mail, right in the browser. And that's a bad thing, because that is the same platform where Alice and Bob are acting on, in the browser, in that DOM, on that page that is being loaded, on that URL. So Mallory can do pretty much whatever she wants there. She can pretty much impersonate those two perfectly well. It was pretty hard to do these things, these kind of cross-site scripting attacks in the past. Because in the past, before the dawn of cryptography in the browser, servers had the possibility of sneak peek into that mail, have a look at the HTML that was being sent around, have a look at the attachments that were being sent around, and sanitize them. Scrub out all the bad stuff, leave only the good, and then everything is fine. So there was a server-side filter, a server-side sanitizer through which the HTML had to go before being shown in the browser. But the bad thing is right now, that is not possible anymore. So the server cannot see these things anymore because the HTML that is part of the message is being encrypted. So the server has no clue what is going on. So this old protection mechanism that we used to rely on and still rely on today doesn't work anymore because the server only sees garbage. The first time when the HTML actually unfolds is when it's being decrypted, and that sucks. So, goddamn encryption. We need to end this, right? It should be forbidden or regulated or backdoored. Well, maybe not. Maybe there is something else that we can do. I hope there's something else we can do. The initial problem that we want to isolate here before having like a more advanced look at what other problems might be lurking in that space is we cannot filter, we cannot sanitize on the server no longer. It's not possible because the server has no idea what is going on. So what we have to do is we have to sanitize on the client itself. So we have to do it inside the browser. Sounds easy, right? Just like use some prepared function that is offered by the browser that says like, hey, clean that chunk of HTML for me and do something good with it. Should be easy, right? Well, one would assume the browsers give us tools for that, and that those tools are really mature and have been existing for years because that's like a super common problem, sanitizing HTML in the browser directly. But unfortunately, that is not the case. These tools do not exist. Not at all. Well, we have a lot of security tools, and you might be jumping up right now and say like, wow, we have all those amazing things that have been invented in the past years. We have sandbox iframes, we have CSP, we have HTTP-only cookies, we have cross-site scripting filters that are installed in browsers and detect attacks. We have web workers to isolate stuff, we have the same origin policy, that ancient thing, we have sub-resource integrity to make sure that no malicious JavaScript from a compromised server can come, and there's so many things, and last but not least, the biggest thing that we have is the content security policy. That policy that controls what kind of script can execute and what kind of script cannot. And Mallory would have a hard time to get something in if CSP is working there. However, all those technologies are not really perfect for that particular use case. They're all quite nice, and if you intersect and overlap them nicely, then you might be lucky and it might just work. But if just one of them is broken, or if just like one of them is slightly damaged, the solution is not usable anymore. I've been researching CSP for quite some time, and you don't want to know how many bypasses I found and reported to browser vendors. So we cannot fully rely on CSP. We can also not fully rely on sandbox iframes. There is not too many things we can fully rely on. And this particular use case we have here, sanitizing HTML in the browser, is not covered, and we need it. So we need to have that. We need to get that. We need to kind of be able to do that. And I saw the need, and I remembered that there was something like that in the past. It was called ToStaticHTML, and ToStaticHTML was an interesting artifact because ToStaticHTML, contrary to many other things in the browser, is non-standard. So someone just like came up with the idea, the same idea in the past, said like, yeah, we need this kind of function that is globally available, and we feed it some HTML, and what comes out is like non-dangerous HTML that cannot execute any scripts. And the only browser you would find this magic function in was Internet Explorer. And I think it started with IE 8, 9, then in 10, then they have it still in 11, and then they killed it in Edge because they were like, ugh, no one uses this anyway. So, too bad. We can only use it in IE. We can't even use it in Edge anymore because it's non-standard. No one ever took the work of writing down what it really does. There was no configurability. There was basically nothing, just like throw in a string, get another string out, and hopefully everything is fine. I contracted with Microsoft for a bunch of years, and we also pen tested ToStaticHTML, and guess what happened? We bypassed it. It had to be fixed. We bypassed it again. It had to be fixed, and so on. So that was not perfect. If you run Firefox with no script, you also get ToStaticHTML. but it's following completely different rules, and Giorgio Maone did a good job in implementing something that is fairly safe, but you don't want to use it. I mean, no other browser has it, either just IE or Firefox with a very specific plugin, so there is no good reliability that you will actually find this thing in the DOM. But we need something like that. So I decided to build it, because why not? It was actually the project part that was following my PhD thesis, where I was trying to fight XSS and actually defeat XSS, and almost made it, but that project was missing. So I created a library, and that library is called DOMPurify, and it does exactly what I was describing. Only that it's like nice and configurable, and you can throw HTML in, and you can throw MathML in, you can throw SVG in, whatever you want. It takes that, it puts that in a virtual isolated DOM, iterates over everything, sanitizes the trees, the branches, and the leaves, and then gives back another string or an object depending on how your configuration looks like, and that is then sane. That's quite good. Throws out the bad, leaves in the good, returns a sane string, and you can work with that thing. It's open source, it's free, we have like super permissive licenses. I thought at the first time when I started implementing this thing that would be an easy task. Just create a virtual DOM, just iterate over the branches, iterate over all that stuff, and sanitize it, but that wasn't true. So the DOM is a huge mess. Like, it's absolutely almost impossible to kind of know in advance what kind of death traps the DOM has for you. Because there's so many weird stuff going on, independently of the browser. There's weird stuff in Chrome, there's very weird stuff in IE, there's pretty damn weird stuff in Firefox, and, well, guess what? Other browsers also have weird stuff as well. And these weirdnesses, these artifacts on the DOM always shoot us in the foot, because effectively they created bypasses. So we had to work around these bypasses and these weirdnesses and kind of create something that we could trust in the DOM as a sanitizer. I noticed that there is no Donald Trump emoji again. I wanted to do the entire presentation as emoji, but not yet. We will see. Anyhow, we believe to have solved all those problems in the DOM, all those weirdnesses. We've maybe hopefully detected all of them and worked around them, and we're actually quite happy because we haven't received any bypasses for months. Despite even generous bug bounties that we give out thanks to a bunch of amazing partners, like for example Fastmail, that say like when you find a bug in DOMPurify, you will get big cash, which is quite nice, and this is as far as we can go. So we have unit tests, we have CI, we have good coverage, we have bug bounty. This is all open source, it has permissive licenses, and it's really great, and you should all use it, right? Many websites are actually already using it. In Germany, we have this failed project, but it still exists, that is a kind of a government-approved email system where you can do your taxes with. Like, nobody uses it, and that's OK. And they call it de-email. And they had the very same problem because they recently implemented E2E, end-to-end encryption. And guess what? They had the same problem. They also realized, oh, darn, what do we do with that markup that is encrypted? That's really bad, and we had a cross-site scripting. We even had remote code execution because it was using the extension that is called Mailvelope, and there we had an RCE because it was running in an extension. And when you run JavaScript in an extension that you can control as an attacker, you have RCE. So they're using DOMPurify, and they're good with it. They're fine with it. And I would estimate, without being like too bold, that there's a couple of hundred of million of users per day that are being protected by my library, which is good, which is great, right? So I guess the problem is solved. We can be done here. We can go home because we don't have that missing part anymore. It's all there. We have a good library. It's well maintained. It does what it's supposed to do, and everything is fine. And I'm now kind of standing here and just like producing myself as the slayer of the cross-site scripting dragon, as an awesome person who created that library and saved everybody from these kinds of attacks. But is that really true? Don't we have like a much bigger problem? I'm turning into the evil guy now, so I think I don't have to be formal anymore. Just like get this jacket off. Fly, little bird. Hell no. Now you have to do something that you didn't have to do before because you have to trust me. I am the maintainer of a library that is being used by many, many websites out there that is protecting many, many people at the same time, every single day in and out. And you have to trust me that I don't fuck it up. Or even worse, I could turn rogue, just so, and build in a backdoor. All that money. And that would work. And no one would notice. Of course, I would like never do that, but I could turn rogue, and I think I could write in a cross-site scripting exploit that you wouldn't see immediately. That would even bypass, well, my own tests. I've been writing cross-site scripting exploits for the past 10 years. I think I could hide something. I would probably hide it in the compressed version that we also deliver, because no one ever checks that. I mean, just like no one has a look at this thing and it's compressed. Like, who wants to audit that? There's like a bunch of bytes that I have to change, and boom, I have a backdoor. And I have cross-site scripting for hundreds of millions of users. How awesome would that be, at least for me? But I would never do that, right? I mean, I would absolutely never do that. You can fully trust me. I'm standing here. I'm just like, I would totally not do that. Or would I? Or would I? Oh, God, that money. I would have to hire a person for money that tells me how to spend all that money that I would make. God, I love that. So, that kind of sucks. I can get the jacket on again, but maybe later. Know what? What kind of options do we have? We see that there's a problem, and it's like an actual real-life problem. And we see that there's a solution, but the solution was created by one dude and a bunch of people who helped. And that one dude, me, has full control over the solution and can do whatever the effort that person wants, me wants, to that solution. And with one click, with one commit on GitHub, I can do really, really nasty stuff. That's not good. We need more eyes on that. We cannot rely on people just creating, providing, and maintaining security libraries. I think there's a solution. And that solution is that we cannot rely on these libraries anymore. We have to have that stuff inside the browser, inside the DOM. The DOM has so many APIs. Some of them are useful, some of them are super useless and are never being used, but that doesn't matter, they're still there. But we need another API in the DOM. We need a sanitizer in the DOM. We need something that is working out of the box, that is fast, that provides a secure default, that has nice templates, and that prevents developers from shooting themselves in the foot. And we don't need this as a library, because then we have to trust someone or a bunch of people. We need this in the browser, where everybody can have a look at and notices when something happens. We need DOMPurify or something like DOMPurify inside the browser core, despite CSP, because CSP doesn't fix the problem. Rather the contrary. It makes sometimes things a bit worse, sometimes a bit better. So we need something that is covering up for that. We need to fill those gaps. We cannot rely anymore on these accidental intersections of existing protective technologies. We have to have something that is covering that particular use case, because that is getting more and more common. And that is good. That's a good thing that it's getting more common. So now you might sit here in your comfort zones, and you might have a look at me and say, like, why didn't you just write the specification? And I'm like, well, why don't you write the specification? I already did all the dirty work. I identified the problem. I developed a fix. I hardened that fix, and it's really working well. I set up all the testing infrastructure, tons of test cases, literally 10,000s of test cases of attacks in the past, future attacks, combined attacks, weird character sets, mutations, and whatnot. I did all that already. I think now it's not my turn to write a specification, but it's actually our turn. What's that?
If you could use that, please.
Sorry, I lost focus. Like I said, I've done the dirty work already. Everything is there. But if you also think that this is like a realistic use case, that we want to make sure that encrypted communication in the browser, where stuff is being decrypted in the browser, right in the DOM, needs to be protected as well, then let's do something like that. We're not starting this project, we're not starting this spec, but we're really, really happy to help with test cases, with implementation, with support, with experience. We've helped countless users to actually set up DOMPurify on their websites. We kind of know what developers want, but we're not going to get into this battle of writing the specification. It would be great if someone else did that for us, or with us. So my call to action here is that I would really like if you could take all those Electron mails and all those other tools that do the very same thing, and all those plugins and all those add-ons and those extensions, and make them a little bit safer by giving them the only API that is still missing for them, and that is client-side sanitization. We shouldn't and we can't do this on the server anymore. We can't do this with some obscure application firewall or IPS anymore. We can't do this on the network anymore. We have to do this in the browser, and that's like the only place, because that is where the action happens. So that concludes my presentation, and I hope some of you liked it and see it's like a call to action and don't think it's like too useless what I'm proposing. And if you don't, then just like talk to me after the presentation and maybe we can find something out. Oh, there's good news. Actually, I spoke about this issue with two Googlers, with Dave Ross and Mike West. That's why they were referenced in the slides without knowing. And they couldn't help
they couldn't keep their fingers still, and they actually started working on the specification already. And there's already a mailing list thread where just like people are doing cake fights, the usual mailing list style, and discussing the issue. And it's moving forward, so the first step is already done. It just like happened yesterday or the day before yesterday, so that is good. Let's see what's coming out of that. And that's it. Thank you very much.